Okay, great. Thank you so much for inviting us to join. I want to talk to you a bit about Xeros, a company based in the UK, and we focus on denim washing. So let's start at the beginning. By 2025, the water scarcity will affect over a quarter of the world's populations, as we know, and that's why we're here to try and find sustainable solutions for the future. The sector we work in and we're looking to go into is the fashion industry, which is one of the highest consumers of water and polluting the waterways. So we're just really setting the scene. Here's a few numbers to think about how much water it takes to make the amount of jeans that we make in 1 year globally. So this is where we bring you on to the technology that Xeros do today. So introducing the XFN. So this is a closed loop system that has been devised that can fit into any drum. It's designed to be inserted into any drum. It's two parts. One is like the unsung hero you don't see too much, which is the X drum. And the other part is the XOBs, which are the small polymer beads that you see in the drum. So let me talk about the XOBs first. So the XOBs are designed to be reusable. They've been tested up to 10 years plus with minuscule 0.0 something of weight loss. They can be recycled later as well because they're a nylon. They reduce water and chemistry by being in the drum. They're a physical element that can move around and drive chemistry in. So this being a detergent, an enzyme, some kind of tinting, or any other kind of chemical that you'd put in. These are quite different to stone washing, but straight away you'd think, oh, okay, it's replacing a stone washing. It's a non-friction XOB and it's non-abrasive. So it's the polar opposite, and it's a lot smaller than stones, but it can give you some of the effects. So anything you put in the drum, it will increase effect. So if you want abrasion with enzymes, it can increase it. If you want to drive tints in, it can do that. And also with the offset of the amount we put in this with the water, it reduces a lot of this. So that will reduce the water by 50%, say, and that can reduce the chemistry that you need. And also it utilizes what's in the drum. And then because there's so many in there, between 40 and 600,000 of these, it's repeatable finish every time. So here's the extra, which is the unsung hero, I would say. It has two parts to it. One is the arms, where you see on the lifters, it's got like a herringbone system that will take the XOBs out and take it to the back of the system, where you see a small area that it holds. So if you don't want them in the drum, you keep the middle bit, which is called the poppet, closed. So nothing will come, and it will keep harvesting through those 5 lifters you can see and hold it into the back compartment. And then when you want to let them back in, you simply open the poppet and it comes in. And because it's constantly being harvested and coming through, it's cycling through the load inside the machine. So here you'll see the actual machine in action. So you see machine loading, you won't have anything in it. You'll load your jeans in, and then you start your normal process that you do. So you'd start with something like a D-size, and you can pick and choose at each step if you want to add these XOBs in. So if you want to increase the effect or you don't want to increase the effect, you can open and close the poppets. It can take around, below 10 minutes to get them out. But when you put them in, it can take 1 minute, I would say, to put in. So you open the poppet at any stage you want, and then it's in, it's driving the chemistry deeper, whatever the effect you're looking for. Here, this is an enzyme, but a dry process. So you see the XOBs in there already during the D-size, so they're ready, available. You put your enzyme in and you tumble. So the garments are wet from the D-size, and then you just simply tumble. And then going through to some eco version of bleaching, we can do through nebulizing system. And because this is low water, the XOBs work better because whatever's in the drum, they utilize. So they move it around and drive it into the product. So the less water you have, means there's more available product. If this is chemistry or what dyes or tints or whatever you have in here, it can dry in deeper. So actually the sustainability aspect of water is a byproduct of the system, how it works. And then you see at the end, you take the jeans out and all the XOBs are gone in this process. So here's an example of one of the clients worked with in Europe, one of the big European suppliers, where we looked at it, how much water can you save? And it's recipe to recipe. because it's a science-run company, everything's data-driven. So it's how much water's gone in on this one and how much you have put in this one, or if it's to do with color, we use some kind of spectra data. But here it's a lot of physical elements. We haven't got pumice, obviously. We reduce the enzyme, we reduce the energy, and then the water. And this byproduct, so if you've got less water, you don't have to heat as much water. So therefore, you automatically save energy. So a lot of it's quite logical, how the savings come through. So here is a few of examples. Some wash recipes, take up to 3.5 hours and can have like 34 steps in them, taking out, drying them, wetting them, bleaching them, and loads. So looking at just I'd say the 6 key steps: desize, which we need to prepare the garments, then into abrasion, where we're obviously going to braid it, and then bleaching to change the color of what we want to do. And then nebulizing can be a bleach, but an eco bleach or an eco enzyme, or depending what you want to do. And then through to tinting, which is one of the finishing steps, and obviously softening if you need to do this, because XOBs are non-friction and smooth. Generally, in the test runs, we don't add softener because it's not needed, because it's just gently rubbed the chemistry in with a non-friction product, so it retains a lot more of the softness. So the first one is enzymes. So this is 2 blankets. You can see the top row is without XOBs and the bottom row is with XOBs. And it's quite simply starting from 15 minutes, going up to something like 90, 120, and every 15 minutes taking one out to see what happens. So you can see as it goes through, it's normally, I'd say from 35 minutes onwards, you can see a big noticeable difference. It does start working before, but it's less noticeable in simple abrasion, but when you do bleaching, you'll see it more. So you can see it takes more off. So it's the same machine, it's probably the same day, it's the same chemistry used, it's the same amount of water used, same ballast weight used, and simply just adding the XOBs in the abrasion steps. In this step, actually in the desize process, there's no XOBs in both. So it's just purely the XOBs, what it did in that step. And then nebulizing, what I was talking about earlier. So this is using an eco bleach that we got from Europe. Looking at if you add it into the step where you nebulize for say 20 minutes and you tumble for 20 minutes more, what the XOBs would do in this step. And as you can see, it's a lot lighter on the left, which is the XOB one, and on the right, it's without XOBs. And without XOBs, nebulizing, normally you have to reduce the load size a lot. And also you might get some patching. So you see it's slightly patchy near the top end. What the XOBs are doing, being in there, like you'd have like say 8 garments in this test machine and you have 40,000 of XOBs. So they're gently moving it, all the chemistry around and rubbing it in. So after you sprayed it all in, the homogenizing part is done with the XOBs, rubbing it in. Again, foam process is quite similar to nebulizing. It's a low water. So we're 1-to-1 here, like 1 liter to 1 kg. Here we've run smart foam, which is a system that uses enzyme it can use bleach as well, but we use enzyme with foam we pumped in, and then we add XOBs in one and not in the other, and we run the process again. This might have been something like 45 minutes, but you can see it's a huge jump forward, and it's literally the same day, same chemistry, same tumble time, just adding the XOBs in here. And then tinting. So tinting, we test 0.5, 1, and 2, and you can see the difference visually. So we need to back all of our findings up with data. So here we've done all the data, delta E spectro data. So yeah, I give a great example here. On the 2%, we literally tint it for 10 minutes at 50 degrees, direct dyes in, and we tumble it, and we've got a change of 2.49. So to put that in context, anything over 1, your eye can visually see. So this is quite a difference. And you can obviously see on the screen, there's a difference between it. And then even going down to 0.5, that's just under 1. It's like 0.94, and then 1% is 1.49. So it's quite a good savings. So you can either, if you wanted it darker, then you're going to, without XOBs, you're going to have to add more tints. Or if you needed the lighter option, then you just reduce your chemistry use. And the idea here as well, in the effluent, there'll be less dyes. So going to effluent, less to be cleaned, less, you could say pollution, but obviously everyone's got ETP plants. And then testing the garments. So if XOBs are increasing the effect in less time, then this is a benefit, obviously, on the time. We can reduce the chemistry as well here. But what you can see from this data that we've got is you can save and improve your tensile tear which is an automatic response to having less enzyme in contact with the garment for longer. So here, you know, in the warp tear, you'd have 30%. And then the warp tensile will be similar. And then the weft we found around 10%. And this is pure data-driven testing in-house with all the garments that we've been testing across different fabrics that we've been getting from Pakistan, Turkey, Italy, and then just seeing how the effects come through tested and wide scale. And then other things as well. So looking at things like sulfur groups, yarn dyes, garment dyeing as well, we'll be looking at because it drives tints in, so it should be driving some other things in. When you categorise garments, you need a uniform garment before you dye it. So actually having XOBS there is a benefit, I would say, as well. And then here's another case study actually we did to show even at the wet out point, which is the D size, we saved on water because the system we're using. And then as you go through, it's the logical thing. If you're saving on each step, it's gradually getting wider and wider, and the savings are getting bigger and bigger. So if you used it in more steps, savings are more. And that's it. Thank you very much. If you'd like any questions or any more information, I'm here for you. But also, that's our website if you want to go and check the website. Thanks so much.